So regression line fitting lab, we are going to work on the same data set, air passengers data, week on week air passengers, and some of the factors that will impact the air passengers number. We have to find the correlation between promotional budget and passengers. We have found it out, and in fact it is 95% or more. Draw a scatter plot between promotional budget and passengers. Is there any pattern between promotional budget and passengers? We will see that. If the promotional budget is 650,000, how many passengers can be expected in that week? So basically, now we are trying to give a problem. If the promotional budget is X amount, what is the expected number of passengers? Since correlation can't do anything there, we had to find a regression line. Then using the regression line, it simply formulates y equal to beta naught plus beta 1x, that is number of passengers equal to some value of beta naught that we are going to find out after line fitting, some value of beta 1 into the promotional budget. Now once we fit that regression line, we can simply substitute the value of promotional budget in the x position. Simply we can find the value of y, that is number of passengers. Build a linear regression model and estimate the expected number of passengers when the promotional budget is 650,000. So simply that's what we need to do. So let us see how it is done. First, correlation between number of passengers and promotional budget, that is 96%. That is very high correlation. Plotting promotion budget on x-axis, number of passengers on y-axis. This is how we can plot. It is very evident, very clear that on x-axis promotional budget, on y-axis number of passengers, you can see there is a very high correlation. As the budget increases, that is promotional budget, on reducing the ticket fares, giving the coupons and giving the offers, if that we increase that, definitely number of passengers are really growing high. If we spend a little very less amount in a particular week, then we see the number of passengers are low. Now what we need to do is we have been given a specific problem, that is when the number of passengers, what is the number of passengers when the promotional budget is 650,000 or so. For that we need to build a linear regression line. How do we build that? We have to use a function called linear model. So LM stands for linear model. What do you want to predict? That is number of passengers, or simply you can say $8 number of passengers, or number of passengers tilde promotion budget. Comma within the data set, that is 8. You need to observe this carefully, the code that we are trying to write. This is the code LM, that LM stands for linear model, number of passengers, that is what I am going to predict. So the line equation finally that I want to put is y equal to beta naught plus beta 1x. Here y is passengers, x is promotional budget, and then that is in the data 8. So we don't want to print the model as it is. We want to save all the results of the model in an object called model1, and then we'll see the summary of model. So simply I'm fitting a linear regression line, which is simple, and then see the summary of model 1. When we say we have fit a regression line, what did we do? We have found out the values of beta naught and beta 1. Beta naught is also known as intercept. Beta 1 is also known as slope of promotional budget, but we can simply ignore that. Beta naught value, the intercept value, is this in this particular model. Then the promotional budget coefficient is this. If you have to write a regression line, what you will be writing is number of passengers equal to this value, that is beta naught value, plus promotional budget into this, or beta 1 value into promotional budget. Now you can simply substitute promotional budget there and then find the value or the predicted value of y, which is nothing but number of passengers. Once again, that is y equal to beta naught plus beta 1x. Here your x is promotional budget, beta 1 is this value, beta naught is this value estimate, and then y is number of passengers. That is how you can simply find it out. In fact, I can go ahead and even simply draw a regression line how it has been fit. We can use the same regression model 1 and try to draw a line that we have just fit. This is just for our understanding. We'll try to draw a line, but we don't need to do this every time we fit a regression line. Simply let's try to draw this line. This looks like a good fit for this particular given data. What we need to do right now is, given the promotional budget is 650,000, what is the estimated value of number of passengers? You can simply write down the line, use Excel or calculator to do that, or you can even write the formula within R to find out the prediction, or you can use predict function. If predict function doesn't work in your case, you can use some other ways of finding it. Simply here I'm creating a new data frame for just this value, so that is new data, and then predict using model 1 that we just built. That means model 1 will hold that y equal to beta naught plus beta 1 x, y is number of passengers equal to beta naught value plus beta 1 value into promotional budget. So using that model, I can see the estimated value of number of passengers is 46,453. Simply 46,453 is the estimated number of passengers, which we were not able to predict using simple correlation. Now you can predict by fitting a linear regression line. Even you can change the value. Let's say if you are saying the promotional budget is this much, what is the predicted number of passengers? You can say that yes, this is the predicted number of passengers. In fact, we can even go one step further and say, what if I want to make the number of passengers to be 50,000? If I want 50,000 passengers, how much budget I can spend? So let's say promotional budget 650,000, fetched 46,000 customers or passengers. Maybe instead of 650,000, I'll spend some 700,000. Then expect number of passengers to grow. Let us see what is the estimated number. So with 700,000, you can see almost 49,930 customers. So basically, you spend around 700,000 worth promotional budget, you will get almost like 50,000 customers near your whatever your target is. So that is how you fit the regression line between two variables that are highly associated and try to formulate one equation, so that given the value of one variable, you can always find out the value of other variable.